Today we're going to continue our lessons in logic and reasoning and proofs, and we're going to continue with what we call conditional statements. Familiar with statements, we call them P, Q, R, S, T. Any statement that is either true or false, not both, and is not an opinion. For instance, there is a pep rally today. True or false? You can make that determination. It is Friday. True or false? You can make that determination. It's not an opinion like, I like Fridays. Yes or no? Well, some people do, some people don't. That would be an opinion. Conditional statements are statements that can be written in a form statement that can be written in if then form. Okay? If then form. Let's use what we've got. If there is a pep rally then it is Friday. Okay, it's a statement that can be written in if-then form. There's a pep rally, it's Friday. It's a pep rally and it's Friday. It's Friday and there's a pep rally. If there's a pep rally, then it is Friday. So a conditional statement is a statement that can be written in an if-then form. Now, two other definitions we need to bring up here is number one, this right here, whoops, not including the comma. This portion right here is called the hypothesis. Notice it does not include the if, nor does it include the comma. Okay? This portion right here is called the conclusion. Okay? So, on a conditional statement, an if-then form, you have an hypothesis and a conclusion. The hypothesis is the part that comes immediately after the if. Notice immediately after the if, it does not include the ifs word. The conclusion is a phrase that comes immediately after the then. Hypothesis does not include the comma, does not include the if. Conclusion does not include the then or the period. Simply the phrase. Okay? Hypothesis is always connected to the if, but does not include the if. Conclusion is always connected to the then, but does not include the then. Alright? It's our hypothesis and conclusion. Now, we can also identify these with statement symbols, just like we did before. Our hypothesis here, we could call statement P. Our conclusion, then we would call statement Q. Alright? The way we would write this symbolically is this. P, then Q. Alright? The way you read it is P, then Q. Or you could read it P. Let's spread that out a little bit. P implies Q. If P, then Q, or P implies that Q is true. All right? So let's play with it a little bit. Talk about it, mess it up a little bit, go from there. You can also come up with and use truth tables with them. Set this up, TTFF, TF, TF. Okay? Symbolism is this. If the hypothesis is true and the conclusion is true, then the conditional statement is true. Okay? If the hypothesis is true and the conclusion is false, then the conditional statement will be false. If the hypothesis is false, but the conclusion is true, then the conditional statement will be true. And here's the one that can get you. If the hypothesis is false and the conclusion is false, then the conditional statement is true because neither condition has been satisfied. Let's run through those just a little bit. Let's say that our hypothesis is there is a pep rally. And our conclusion is it is Friday. Okay? So, if there is a pep rally and if it's Friday, it's obvious, that's a simple one. If there's a pep rally and it's not Friday, then it's not Friday. It doesn't matter that there's a pep rally. For instance, if the pep rally is held on Thursday, if there's a pep rally, then it's Friday. No, we had the pep rally on Thursday. So therefore, the statement, if there's a pep rally, then it's Friday, just isn't true. Let's try this one. If there's a pep rally, then it's Friday. Well, there's no pep rally. Can it still be Friday? Sure. It's still Friday. It's just that the condition wasn't out there to start with, but it's still Friday. Get this one. Is there a pep rally? No. Is it Friday? No. Okay. Then the condition was met. If there's a pep rally, then it's Friday. Well, it's not. There's no pep rally, and there's not Friday. Oh, okay. All right. So if neither one of them are true, then the conditions are met that, oh, well, okay. We didn't expect there would be a pep rally because it's not Friday. We didn't expect it was Friday because there's no pep rally. Okay? And this is what the truth table looks like. All right? Now, there are some other things that go along with this. It's what we call related conditionals. I'm going to go over here and I'm going to extend this truth table, include a whole bunch more stuff. Okay? Put this up here like so. We're going to P up. We're going to put our Q up. We're going to knot the P. We're going to knot the Q. We're going to have our P, then Q, then we're going to have some other things. Well, let's set this up again. TT, FF, TF, TF. What's this? FF, TT, FT, FT. These two are true. It's true. If the conclusion is false, it's false. If the conclusion is true, it's true. If they're both false, then conditional is true. Now, we can also do, this is called the conditional. Conditional statement. We can also have what's called the converse. Now, the converse looks like this. If Q, then P. So how would you read that? That would be like saying, if it is Friday, then there's a pep rally. Okay? So what would that look like? If it is Friday, let's flip these two around, okay? That's still going to be the same. Now, P is a conclusion, so if the conclusion is true, it's going to be true. Okay? P is a conclusion, it's false, so this is going to be false. They're both false, so it will be true. Alright? And that's known as the converse. Okay? The fact that we can flip these things around and call that the converse. Now let's look at a different one. Another one still. And it's called the inverse. What do you think we're going to do with the inverse? We're going to knot it. We're going to take the original conditional and we're going to knot it and we're going to call it the inverse. So that's going to look like this. If not P, then not Q. Okay? So, if not P, then not Q. They're both false. This is going to be true. If not P, then not Q. Conclusion is true. So they're going to be true. If not P, then not Q. The conclusion is false, so it's going to be false. If they're both true, then it's going to be true. Okay? That's how an inverse works. Now, how would we say that? Well, if our original conditional statement is, if there is a pep rally, then it is Friday, then this would read, if there is not a pep rally, then it is not Friday. If it is not a pep rally, then it is not Friday. Okay? All right, there's one more I want to introduce, and then we'll come back and we'll actually write these things out so you can see them. This one is called the contrapositive. Contrapositive combines the converse and the inverse to give you something that looks like this. So a reverse of this. If not Q, then not P. So what we're doing is we're looking at these two and flipping them. If they're both false, we know what? It's going to be true. We flip these. The not P is your conclusion, so therefore that's false, isn't it? Because the conclusion is false. We're going to flip these two, so the conclusion is your not P, so the conclusion is true, so that's true. These two are both true, so it is true. I want you to notice something. How would we say that? We're going to flip these two, and then we're going to put knots in them. So that would be, our conditional is, if there is a pep rally, then it is Friday. So our contrapositive would be, if it is not Friday, then there is not a pep rally. Say it again. The contrapositive would be, if it is not Friday, then it is not a pep rally. Okay? Write those down that way so you can see them. Not P. Not Nat. Not. Okay? And not Q. All right. It is not Friday. Okay? So what we've got is we've got related conditional statements. All right? Related conditionals. The converse, the inverse, and the contrapositive are related to the original conditional statement. Okay? Now, you notice something. Look at this. The truth values of this conditional are T, F, T, T. Any of these over here have the same conditions? Yeah. Contrapositive has the same conditions. Now look at this. The converse and the inverse also have similar, identical conditions. Okay? So what we're going to do is we're going to call this right here, all right? And these two right here, these are known as logically equivalent statements or conditions. Why? Because the conditional statement and the contrapositive are logically equivalent. They have the same truth values for the same conditions. Okay? Converse and the inverse are known as logically equivalent. Why? Because they have the same truth values for the same conditions. Okay? Alright, let's erase this truth table. Got it there on tape so you can look at it as long as you want to, get as bored of it as you want to. Go back and study it. And let's write these out. We've got our original statements and we've got our negations of them. So let's see what we can come up with over here on the side. And we're going to use different colors. Our original conditional. Conditional statement. If there is a pep rally, comma, then it is Friday. Oh, don't know what I'm thinking about there. Friday. Alright, that's our original conditional statement. Now let's put the converse up there. Converse, we're going to switch the conclusion and the hypothesis. If it is Friday, then there is a pep rally. All right? Okay? Now, let's do the inverse. Oh, not that one. Let's do the inverse. Inverse is the conditional, except we're going to not everything. If there is contrapositive. Contra meaning against, positive meaning I don't know what, but contra this one. Contrapositive, it is negative and it is opposite. So negative and opposite would mean I want this and this combined, so we're going to take this one and flip it around. So the contrapositive would be if it is not Friday, then there is not a pep rally. Okay? Got our original statements over here. What's a boundary right here? Our original statements over here and their negations. And then we've got our conditional statement that we made from our original statements. Converse, which is flipping the hypothesis and the conclusion. The inverse, which is taking the original and using the negations. Contrapositive, which is taking the original, conversing it, and negating both the hypothesis and the conclusion. Now, we've taken quite a few simple concepts, rearranged them, got a whole lot of stuff to deal with here. Suggest you look at this, you watch it over and over until you understand what's here and you understand the vocabulary words. Conditional statement, hypothesis, conclusion, related conditionals, conditional, converse, inverse, contrapositive, logically equivalent. All of those are your vocabulary words you need to have a good understanding of for 2-3.